Hello everybody, welcome into another lesson. So today we are going to talk about the slope of a line. So you're given in general, if you have 2 points on the coordinate plane, some arbitrary points x1, y1, and then x2, y2. I know we're getting familiar with those arbitrary points by now. They're just 2 ordered pairs in the coordinate plane. Not only so far can you find the distance between them, the midpoint between them, now you can also find the slope of the line formed by connecting those 2 points, going through those 2 points. And again, this may seem like a review from algebra because we did touch on this in algebra. The slope is often abbreviated lowercase m. The slope is the rise over run. So it first goes by how much it rises or falls. A fall is a negative rise, if that makes sense. It's rise over run. It can also be denoted by delta y. Those triangle symbols are the Greek letter delta. Delta y over delta x, which means change in y over change in x. And if you think about it, change in y over change in x, well, if you're changing y, you're either rising or falling. If you're changing x, you're either running to the left or to the right. So the slope is delta y delta x, which to get the real formula from the delta y delta x, it's the difference of your 2 y coordinates, your second y coordinate minus your first y coordinate, divided by your second x coordinate minus your first x coordinate. That's the formula to find the slope of a line. And then there are some things about the slopes of lines. If you get a positive slope between the 2 points when you connect them and going through those 2 points for that line, if the slope is positive, the line rises to the right, as we see here with this example. With this line right here, it starts out the bottom. The further right you go, the higher up the line goes. It rises to the right. That's a positive slope. Now, if the slope is negative, the line falls to the right, as we see with this line right here. It starts out up high, and then the further right you go, the more you fall down. That's indicative of a negative slope. And then there's 2 other types of lines we can talk about. If anyone remembers from pre-algebra and algebra 1 the saying Vux Hoi, that's coming into play here in geometry also. Vux Hoi. What does that mean? Vux stands for a vertical line. So if the line's straight up vertical, it just stands straight up, that means the slope is undefined. We can't define the value of the slope. And the equation is x equal to some constant. I just call it c for what it's equal to. C denotes some arbitrary constant, whether it's 1, -1, 2, -2, 100, -100, you name it. It's just x equal to some number. So Vux, vertical line, undefined slope, x equals c. And here's the vertical line. Now the Hoi component, so you have a horizontal line. It lays straight flat down with no slope whatsoever. Hoi, it's a horizontal line, 0 slope, so the value of the slope is 0. And then the equation is y equals some constant. And I made c the arbitrary constant. And again, it could be any value for the constant. It could be 1.5, it could be 3, it could be 5/8, it could be any of those. So those are your Vux Hois. Now we're going to do some examples here to find the slope of the line. Okay, so let's see what our very first example is here. We're going to find the slope between the points 1, 2, and then 3, 4. So we're going to find the lines between the we're going to find the slope between the lines, between the points 1, 2, and 3, 4. So to find your slope, denoted M, you take your second y coordinate, which would be 4, minus your first y coordinate, which would be 2, over your second x coordinate, which would be 3, minus your first x coordinate, which would be 1. Which 4 minus 2, that's 2. 3 minus 1, that's 2. So you get a slope of 1. So you got a slope of positive 1 between the points 1, 2, and 3, 4. That of course is the line that connects those 2 points and runs through those 2 points. If we remember back into very early in the course, through any 2 points is a line. Remember that? Yeah, through any 2 points is a line. So not only does the line connect the points, it goes through the 2 points in either directions. You have a slope of positive 1, so it's going to rise to the right. Okay. How about the next ones? You got, well, they sure love the point 1, 2. So we're starting again with 1, 2, but your second point is negative 2, negative 5. So we have to find the slope between the points 1, 2 and negative 2, negative 5. So lowercase m will denote your slope. It's going to be, of course, your second y coordinate of negative 5 minus your first y coordinate of 2 over your second x coordinate of negative 2 minus your first x coordinate of 1, which would just give you negative 7 over negative 3, while a negative divided by a negative is actually a positive. You got a slope of 7/3. And you will quite often get fractional or decimal slopes. That does happen quite a bit. So the slope would be positive 7/3, which again would be a line rising to the right. The further right you go, the more the line's going to rise. Okay, let's see. Now, boy, they sure love that point 1, 2. Let's do the point 1, 2 again. Let's see what this second point is this time. Now it's going to be negative 2, positive 5. So what if we had the point 1, 2 and then negative 2, 5? So m is your slope. Take your second y coordinate of positive 5 minus your first y coordinate of 2 over your second x coordinate of negative 2 minus your first x coordinate of 1. Well, that's going to give you 3 divided by negative 3, which, you know, 3 divided by negative 3 is negative 1. So the slope of the line formed by those 2 points is actually negative 1. So since it's a negative slope, it would look like a line falling to the right instead of rising. It's actually going to fall the further to the right you go. And as we get into Algebra 2, which is the next course after this, we will talk more about left and right-handed behaviors of graphs, especially not just linear as we're doing in this course. We'll talk about quadratic and cubic and other functions. Alright, so we got to find the slope between 0, 0, the origin in other words, and then 5, 1. So we got to find the slope between 0, 0 and 5, 1. So take m for your slope, set it equal to your your second y coordinate of 1 minus your first y coordinate of 0. Divide all that by your second x coordinate of 5 minus your first x coordinate of 0. Well, that's just going to give you a slope of 1/5, and positive 1/5 at that. So the slope of the line between the origin and 5, 1 would be positive 1/5, which would be, again, since it's positive, the line would rise to the right. Okay. I got about 5 more problems. What if we were asked to find the slope between 7, 2 and 2, 7? So we have to find the slope between the line that goes through the 2 points 7, 2 and 2, 7. So there's your slope. Let's see, that's going to be your second y-coordinate of 7 minus your first y-coordinate of 2 over your second x-coordinate of 2 minus your first x-coordinate of 7. So 7 minus 2, that's 5. 2 minus 7 is negative 5. So you have 5 divided by negative 5, which would give you a slope of negative 1 for your line. And a slope of negative 1, the line would fall further to the right. The further right you go, the line actually falls. Okay, 4 more. What about the slope of the line 3, 3, between 3, 3 and then 3, 7? Okay, so we got to find the slope of the line that goes through the points 3, 3 and 3, 7. So let's go ahead here. Of course, you're going to take your second y-coordinate of 7 minus your first y-coordinate of 3, divide that by your second x-coordinate of 3 minus your first x-coordinate of 3. Well, 7 minus 3 is 4, 3 minus 3 is 0. Well, hang on a second. Division by 0 is undefined. So you can say m is undefined, or abbreviate it UND with a period. The slope is undefined. So what does it mean that the slope is undefined? You would have a straight vertical line going through those 2 points. So it would be a straight up vertical line. If you remember VUX, vertical line, undefined slope, x equals. So it would be a vertical line through the points 3, 3 and 3, 7. Okay, I just have 3 more problems. So we got the points 6, negative 6, and then negative 6, negative 6. So we have to find the slope of the line going through 6, negative 6, and negative 6, negative 6. So let's go ahead and do that here. So take your second x-coordinate of negative 6 minus your, I'm sorry, did I say x? I'm sorry. Take your second y-coordinate of negative 6 minus your first y-coordinate of another negative 6. Divide that by your your second x-coordinate of negative 6 minus your first x-coordinate of 6. Well, what is negative 6 minus negative 6? That turns into negative 6 plus 6, still over negative 6 minus 6. Now, what is negative 6 plus 6? That's 0 over what is negative 6 minus 6? That's negative 12. Well, I think it's plain to see you're going to get a slope of 0. So the slope between 6, negative 6 and negative 6, negative 6 is 0. What does a 0 slope look like? It's going to be a horizontal line going through those 2 points. If you remember Hoy, horizontal line, 0 slope, y equals. So you would have a horizontal line going through those 2 points. And I just got 2 more exercises. Alright, we have again here, at least for the first point, 6, negative 6. And then we also have 4, 3 this time. So we have to find the slope that goes through the points 6, negative 6, and 4, 3. So go ahead, take your second y-coordinate of 3 minus your first y-coordinate of negative 6, divide that by your first x-coordinate of 4 minus your second x-coordinate of 4 minus your first x-coordinate of 6. Well, what is 3 minus 6? That would be 3 plus 6, still over 4 minus 6, which would end up giving you, 9 over negative 2, which when you have a negative in the denominator, a positive in the numerator, you just put the negative in the numerator. So you'd end up having a slope of negative 9/2. So the slope of the line going through these 2 points is negative 9/2. And since it's a negative slope, it would fall to the right. The further right you go, the more the line falls. I got just one more example here. Okay. What about -4, -3, and then we also have -6, -6. So we have to find the slope of the line going through the points -4, -3, and -6, -6. So let's start with our second y-coordinate of -6 minus our first y-coordinate of -3 over our second x-coordinate of -6 minus the first x-coordinate of -4. Well, we can simplify this a bit. What's -6 minus -3? That's going to be -6 plus 3 divided by, then what's -6 minus -4? Well, that would be -6 plus 4, which would end up simplifying into -3 over -2. -3 divided by -2 would turn the slope into positive 3/2. So the slope of the line going through those 2 points would be positive 3/2. Which, since it's a positive slope, it would rise to the right. The line would continue to rise to the right the more right you go. So that's really it to slope of a line. The next lesson, we're going to use the slope to determine if 2 lines are parallel to each other, perpendicular to each other, or neither. So I hope everyone has a good night and take care.